All right. Um, yeah, thank you so much for the kind introduction, and thank you all for waiting till the end of the day. I've been really excited, looking forward to presenting to you all today. And first of all, I want to congratulate all of you for making it to the boot camp because I know it's highly selective, much anticipated process. And I also want to say a big thank you to your entire team for organizing this, and especially to Dr. Bayo Adekombi, who's the lead convener of Data Science Nigeria. And I've had the privilege of participating in these boot camps almost since its inception. So it's really great to be back here today to talk about a topic that is near and dear to my heart. All right. So math. So all of us clearly are interested in machine learning. We're all interested in AI. Can you all hear? Everybody can hear me? Everybody can hear me clearly? Good. All right. We're all interested in AI, but the math sometimes can be, tricky. There can be parts of it where you might say, do I really need this? First of all. Second of all, I know that I need it, but it seems like a lot, to get to where you want to be, which is somebody who is engaged actively in artificial intelligence and is contributing to the field, right? So the first question that I want to answer, or I want us to together address is why math in the first place? Why math? And then second topic is what is the best way to learn this math? All right. And then what is the specific math that I need for ML? Given that there's an infinite amount of math out there, you don't need everything, clearly. There's certain types of math that are essential. So that's what I want at the end of today. I want us to have that clearly in our minds about what is the essential math. First of all, why do I need math? What is the essential math? And then how do I learn the math that I do need? Okay. So, why mathematics in machine learning? What role does this play, if any? Okay. Can you guys see the screen? You can see my screen. I've changed slides. The current slide says why mathematics in machine learning. And then it says math is the language of machine learning. We can see that slide, right? Thumbs up. Yes. So machine learning is a very specific thing, right? It's the idea of learning insights from data and then using those insights, that intelligence, to be able to take actions. That's what it comes down to. And it's all about learning what is the knowledge that is stored inside that data. And invariably, it requires us to be able to describe the data, represent the data, right? And then we have to very precisely be able to measure the learnings that are happening so that we can increase that learning. That's the whole process, the whole idea of optimization. And all of you are here because you've already gone through the process of training ML algorithms and so on. And one of the things that I like is when you say things like import Keras, right? Or import TF dot TensorFlow, import your large language models in Hugging Face, et cetera. You have enormous amounts of libraries that have been built over the last several years that are giving us opportunity and privilege to be able to not have to build everything from scratch. But still, you have to understand exactly what that language is. Why? Because the truth of the matter is, the easier that something is, the more systematic it is, the more easy it is for me to say, import PyTorch, import data, train model, then what that actually does is it shifts the value of the skill set to another place. And you have to stay active and say, where is that place, right? If the large technology company is now able to build a cloud service that can train data just like that with the click of a button by a layperson, then the important thing then becomes for you to know where you need to be focusing yourself in terms of positioning, so that when companies start hiring and start saying, where are the people that have the skills that we need, the skills that we can't just take a credit card and go online on Google or Amazon Web Service or Cloud or ChatGPT, OpenAI, and open an account and click a button and it's done. So those jobs are not jobs anymore, right? So you have to move along with that. And part of what I'm going to be selling to you today in terms of getting you to understand is that part of what's going to be critical is the math, understanding how these things work and how do you bring them together and how do you make them happen. Coding is always going to be important, but it doesn't necessarily bring me great pleasure. This is not news to inform us or highlight the fact that large language models are now able to build standard three web-based apps, three-tier web-based apps, front-end, back-end database, right? You can imagine your Union Bank or GT Bank, Bank of America, et cetera, even e-commerce sites like Amazon.com or Konga or what's the Jumia in Nigeria. And the entire functionality that it has, you can actually now just tell an LLM to build that, right? That's a little bit frightening, especially if you spent the last 5 years, even 2 years, becoming, say, a front-end developer, for instance, and you have that skill set. And then the first time that you actually see an LLM, somebody just types a prompt and say, build me a website that looks like this other website, right? Looks like the front end of Bank of America, but I want the style and the theme to be like this other one. And my logo is orange and this is my brand. And the functionalities on the back end, I want it to be that it's going to require mandate certain security measures, and you can specify those in template and hand that to your LLM and say, I want everybody to have multi-factor authentication before they can log in. All right. And I want the logins and passwords to meet this certain regex. And you just say that and boom, it's built and it's provisioned everything for you. All right. So that's the future that we're going into within the next, we're already there, right? Within the next couple of years, right? So what you have to do is say, how do I position myself so that I can understand where these things is moving to? And regardless, as the economy starts to change, I'm going to be ready. All right. So that's very important to keep in mind, is that some of the skills that we've spent some time developing, no fault of ours, have moved a little bit. And math is going to give us a good position to remain competitive in a vastly and rapidly changing world. All right, what else? Why do we need mathematics in machine learning? One very, very important reason is research and innovation, critical thinking. All right. Mathematics gives you that edge. It gives you that ability to be able to think critically. One sec. You guys can still see my screen, right? Thumbs up. Good. Because I can't see it. 1 second. I clicked something that I probably shouldn't have, but I'll be back. I'm back online shortly here. So here we go. Now, resume. All right, good. So yes, research and innovation is so critical for us. And that's because that mathematics teaches you how to think, and it teaches you what the different patterns are that connect and how and why they connect. Math is almost it's almost like an art or a spirit in some respects. Like there's something inside there, and when you fully like grasp how this thing works, why it works, then you're fully equipped to be able to update that and move it along to improve the state of the art. So research is very critical. And in a rapidly changing world, whereby artificial intelligence, for better or worse, is going to be consolidating a lot of skills and knowledge that might have just been vastly available on the internet or in people's heads or codified one way or the other. You can now train that into the weight of a model that is on somebody's server. And now that person can now build an API that renders a service. And that's a massive disintermediation. That results in a massive shift in the landscape of the economy and the types of jobs that are going to be important in the future, right? So one has to sort of understand how is it that one can position oneself, not just as an individual, but actually as a community, as a group, right? As an entire country, to where one understands these shifts that are occurring and is able to capture and build systems in place that will make it to be where the prosperity is shared, right? Dr. Bayade Kambi wrote a book that's called Tomorrow is Shared, right? And so that idea of a shared prosperity becomes important, but one has to be proactive. You have to be proactive as an individual to read where is the vector of the economy in terms of where it's headed, number one. And then number two, how do you get yourself to where you can be a part of that and not just be a contributor, but also to protect some of those contributions that you're doing. And math is a key way that is very critical in that aspect. All right. So along those same lines, we've all read beautiful machine learning papers, or at least seen them, right? And all of what we're doing today, things like ConvNets and this and the other, and LLMs and diffusion models, were pieces that were put together and were published and presented at meetings. And whenever you see an impactful, important research paper in AI and ML, and you get through the abstract and the introduction, what's the next thing you're going to see? Always, it's an equation. You're going to see a math equation right there. So that's because, again, as I said at the beginning, mathematics is the language of AI. It's the language in which you can describe AI systems and in which they are expressed. So wouldn't it be a beautiful thing for you to be in a position where, regardless of what the ML paper is, that you pick up, when you read it and you open it, you can say, okay, you understand what they're saying. And then bam, that first equation, it's very familiar to you. And just at first glance, you can understand, okay, this is where this is going, and you read a little bit about that. So that's another key part of why the math is so important for us to learn. And then, again, based on this notion that I'm talking about, which is so important, because maybe 5 years ago, some people might have thought AI was hype, but today I don't think you're going to find one person who would say that AI is hype, right? AI is truly reached a critical point, a Cambrian moment where things are changing and will be changing so rapidly in terms of just the way we live our daily lives, the way we communicate, right? You've got satellites in the air now, Starlink, whereby you can, wherever you are on Earth, you can talk to somebody else. And it can be right there on your phone because the connection is truly just literally everywhere that you can go. And we're even getting to a point now where perhaps space travel might be a way to send somebody up in a rocket. And I'm here right now, Houston, Texas. Within 30 minutes, I might be landing in Lagos, Nigeria. That's half hour, right? That's shorter than how long it'll take you to drive from Lagos mainland to the island, right? And why? Because you might be able to go all the way to space and then back. And from space, Houston and Lagos are not far apart. They're right next to each other. So you just come right back down and you're there. And then self-driving cars are now a reality in a lot of parts of the world. Yeah, you have services running in San Francisco, in Pittsburgh, and in China, where a car will just pull up and there's truly no driver. And you just sit there, there's even no steering. And it takes you where you're going and it brings you back and drops you off. And so in a world like that, where if somebody told you they know exactly where we will be in 3 years from now, that person is lying to you, okay? But we do have some clues, and those clues give us opportunity to position ourselves. And again, mathematics is such a key thing to understand because you can then very quickly connect the dots and see what the next steps ought to be, all right? And now, why else? As I said, I already led into this, is patterns and dot connection across fields. It's the language, not just of machine learning, but it's truly the language of the physical world, of our universe. And so it'll give you opportunities because AI is not restricted to one subset or the other. I'll give you an example. For example, signals processing, right? In your daily life, internet, your cell phone, wherever you're headed, if you get on a plane, what is the LiDAR, radar, the navigation systems, the spectrum, all of that is based on signals, electromagnetic signals that permeate the air. If you're sick and you go to a hospital and they do an MRI, those are all signals. And so one critical thing that we might not see is data signals processing, which is so critical for technology, not just for today, but for the future. That's just an example. And so it's an example of how when you're a data scientist and a machine learning expert or practitioner, you are truly someone who has opportunity to impact just about any field of endeavor, because there are certain things that are common to almost all fields, and math helps you to understand those patterns, right? And then once you get that, you can then easily see the dots, and you can easily make good progress, in that regard. Okay, so those are some very important reasons why we ought to learn math. Okay, and why, as machine learning people, we have to take this very seriously. Now that I've convinced you about the importance of math and why you ought to be learning it as an ML person, the next question you have for me, I'm sure, is what's the best way to do that? Okay. And I have a number of answers on that. One that's very important is that, and this is something that I've applied myself in my own life from the time that I've been learning math. And so I want to share this secret with you guys, is that you have to do the forest before the trees, and then the trees before the leaves. Okay. These are pictures that I took this weekend in the Pacific Northwest. And what do I mean by this? What I mean is, when you're trying to understand a mathematical concept, don't jump right into the equations and start, trying to crunch the numbers before understanding what's going on. Don't jump right into the details, because that's one way to get frustrated and to make the whole thing seem overwhelming. And I think that's where a lot of people end up giving up. The first thing is to understand, first of all, what is this about? What is this new field or type of math? And how does it relate to ML? Where is it going to be used? Just the broad strokes, right? And then once that's clear to you, then you can dive into the next level of trying to get and understanding that you don't yet know the details. So not being intimidated by, I don't understand the whole thing yet, right? With this approach, you don't expect that you understand the whole thing before you do. You're just like, okay, I'm starting at the top. I want to see the forest, and then I want to see the trees. Okay, now I understand forest, I understand trees. Let's get into the leaves, and let's talk some more detail. And with that approach, you're always oriented, and you're not intimidated, because you know you're on a journey, and you just have to keep going. Okay, so forest before trees, trees before leaves. All right. First question you want to ask yourself is, why am I learning this? Right. And then what is it going to be used for? Right. Those are important questions. They're utilitarian and practical ways of looking at something, but they are important because there's truly an infinite number of things you can learn in this life. And so it becomes important to prioritize and to be clear-headed and oriented in being selective about what it is that you're learning, and that your time is precious, okay? And then after you understand what you're going to use it for, this math, then the next question is, what is it? And now you're getting to some details. You're getting to some leaves, some trees, some leaves. And then finally, how exactly are you using it? What are the mechanics of that? And at that point, you're very oriented. You're not lost. So you know what are the fine points that you're putting together. And that's a very important thing. All right. And so that's an approach that I've used personally. And I've always found that to be an asset. So another way to learn, or something to be clearly aware of, is that repetition is the key to adult learning. And so I've repeated this multiple times to drive the point home. It's not something that you look at once and then you say, I've got it. Oh yeah, and now I understand it. Matter of fact, after you think you understand it, trust me, go back, after a month and look at it again and start from the beginning and look through the whole thing and work through it, all of it. You'll be like, oh my gosh, I thought I understood it the first time. Look at all the stuff that I'm learning about this same topic. And then go back a third time and look at it again, and it'll blow your mind at just the different parts that are going to be opened up to you to understand. Okay? And when you persist in this type of an approach, you will become an expert, and you have the confidence that you need, right? Because it wouldn't matter to you whether somebody, what big university they came from, or how many degrees are behind their name. You can engage that person in a debate and you'll win every time. If you've gone over a topic and you've looked at it and it has been revealed to you from so many different angles over the years, you will be the expert on that topic. Trust me. So again, one important thing to take away from this is you don't have to understand everything in the first pass. There's multiple passes, and you just cycle through, just like a neural network, right? The neural network doesn't stop after iteration t=1. You're going to keep going. And what happens to the neural network? The neural network gets smarter and smarter and smarter and smarter and smarter with each iteration that it passes through the loop. And so we can learn a lot from neural networks because they so far are demonstrating themselves to be true experts at learning. All right. Now, this one is very important, okay? And it ties into the other strategies that I talked about best way to learn the ML math is when you start out, you have to understand that it's a lifelong commitment. And when you see people that they seem to understand the math, they seem to be speaking the language and so on and so forth, it's often the case that they've put in more time than us, right? It's often the case that person you have no idea, that person might have put in literally 100x the number of hours that you've put in into that same topic. That person is not smarter than you, okay? And there's different scales of this. There's the short-term scale, then there's a longer-term scale over years, and how that learning compounds, right? So what this means is when you are starting on a journey and you say, I want to be a person who is equipped for the future, that is an uncertain future, especially in this day and age of AI, that wherever this thing goes, I'm going to be there. All right. And I'm going to be one of the first people to see what's going on and how to leverage. All right. If that's your goal, you need to know that you're not going to get there tonight. And the fact that you're not going to get there tonight should not be a discouragement to you. If it is a discouragement to you, what it might mean and what it often means is that you are not committed to the long haul. You're not committed to the marathon. A person that's running a marathon, they have a totally different mindset than a person who says, I'm going to sprint and whatever I get, that's what I'm going to get because after 1 minute, this thing is done. Not even a minute, right? I mean, these days, 100-meter dash is, under 10 seconds if you're Usain Bolt or under 30 seconds. So different mindset. The mindset is the long-term mindset. And it doesn't mean that, and we're going to see in the next coming slides, that it doesn't mean you don't become effective rapidly. There's strategy to that. You want to start learning math this year, you can become effective this year, just knowing what's your broader roadmap and where you need to be today. I'll tell you more about that in the coming slides. Let's look at the next one. Okay, a few resources, right? There's a lot of free resources available to you today. YouTube, if you have internet, you can search the topic you're looking for, look at a bunch of videos, read up on that. I mean, watch them. You'll see different things, different sides to it. You'll be applying some of these strategies I've talked about, including repetition being the key to adult learning, seeing things from different sides, and putting in the time that you need to put in. Another great resource are blogs, right? Things that are written not in the inaccessible language of research scholars, where it might be a lot of jargon, like the same 5 people have been talking to themselves in academic circles for the last 10 years. And when they talk, no one else can understand what they're saying. So that's not where you want to start, right? Because that does you no good. But somebody who understands the topic and is breaking it down to you in layman's terms, that's a great place to be. All right, especially when you're looking at a new topic. So something like Medium blogs. And then when you run into some obstacles and you need a very specific, you have a very specific question, you just Google it. And oftentimes for online forums like Stack Overflow, 10 other people have asked that question in the last 5-10 years. Sometimes 60 other people have asked that question and have commented on it back and forth. Maybe 15 people have answered it in different ways. Some have come and argued with the other people's points and so on. And so now you've got this historical archive of people who were exactly where you are in that moment and the way they circumnavigated that. And that's not just in terms of the mathematical content knowledge, but even the code, like there's a bug that I've run into and how do I solve it? Boom, there's online forums for that. So definitely be taking maximum advantage of that. And then here, this is a shameless plug, or this is no shame at all. I'm plugging this book, which I've been talking about on LinkedIn for a while now. And this is a book that I published April, and I'm very thankful for the support of the community here. So books that are not pretentious. Again, when you're a learner, you have to look out for yourself in the sense that you have to say, who's going to tell me this stuff in the way that I understand it so that I will be smarter, so that now I've got the knowledge and the power that I need to go where I need to go. Those types of books. So this is a book that I wrote that is under 400 pages, and it contains every major AI algorithm and the math to understand that in 400 pages. So clearly, I couldn't be filling it with a lot of jargon that was not essential. It's the essential stuff. So it has to be accessible. And people have told me that in Nigeria, they can't get this book on Amazon and so on. You know, I've got to find a publisher, get it to where people can get this and it's affordable. I have to look into that. Somebody told me they can't get the book in India. So I didn't write this book just for people that are in Germany and in the US. That was not my intention. So we have to solve those problems, okay? And something that is accurate. So that's important. So look for resources that are looking out for you. That's what's important, okay? Now, what math do I need to know for machine learning? What type of math do I need? I love this challenge. This is, so I often pose this question probably about once a year. I'll say there's only 3 things that you need, and it always generates a lot of interest because it's shocking. It is shocking, frankly, that you mean there's only 3 things that I need for AI, no matter what the algorithm is, no matter, you just name it, whatever has been or will be, there's 3 areas that are covered, that covers all of that. Calculus, linear algebra, and probability, and there's just about nothing else. You know, of course, that's a controversial statement, so it always generates a lot of interest and dialogue, but at the end of the day, it turns out to be right, all right? So, and I've just put up here some examples of that. For instance, with calculus, it's just 2 things, right? It's derivative and it's integral. That's it. So again, when you're starting a journey, you need to look at the journey and say, I can do this. Okay, there's this hill, you're climbing this mountain. You can say, I can climb this mountain, all right? I can get to the top of that hill. You know, I have the strength, I have that hill is not that high, it's not that tall, right? If I start now, before it's nighttime, I should be at the top. It's not so bad. That's important. Because on the other hand, if you said, there's no way I'm going to be able to do that, then, you know, the person's already out. So one truth that's very helpful is this one, is that there's truly just 3 things that you need to know at the fundamental level. What's this up here? This is really just a statement of the relationship between the derivative and the integral, all right? This is calculus. This equation pretty much sums it up in terms of the work of Wilhelm Leibniz and Isaac Newton. They were fighting back and forth about who actually discovered the calculus, and that was around the mid-1700s, thereabouts, 1750 something, around that era. And then another very important thing is linear algebra. When you talk about basis and vectors and data representation, that language is the language of the physical world, and it is the language of machine learning. And then probability, which is, you know, probability distributions, like a Gaussian, things that, you know, you sum it up to 1. That's the way data is expressed. Does anybody know the name of this up here? I think I heard somebody say it. Yeah, or type it. I'm sure a lot of you do. And it's Bayes' theorem, okay? So good. So once you're equipped with that, then you know that you're ready for the journey and you're going to get to the top of that mountain because you're like, okay, not so bad. There's really just, you mean AI math is just 3 things. And those 3 things are, you know, things that are not unfamiliar in any way particular. So what I have here is a convolutional neural network, right? And all of you know what this is. You've worked in this, you've done you've done competitions, you've been on Kaggle, you've made it to the bootcamp of data science Nigeria, And I made a big claim in my prior slide. I said there's only three things you need to know. There's only three math that you need to know for anything in AI or anything that's going to be invented in AI that's going to be important in the next 50 years. It's going to come down to those three things, okay? So when you're training a model, which is the fundamental activity of AI and machine learning, we're doing weight updates. We've all heard of stochastic gradient descent. That's the optimization process whereby we update our weights to get our loss function lower so we can meet our objective. And at every step of the way, for every node in the chain of that neural network, you're having to do this activity up here, right? You're having to update the weights. And that comes down to calculus because you've got here a derivative. And what it's telling you is that I'm going to change this weight at every node in a way that makes the loss go down. Well, to do that, you have to know how the loss is, how that particular weight affects your loss. And how do you do that? Chain rule, okay? Chain rule was first used in 1764 by Leibniz. And he used it to find the derivative of a composite function, which was square root of x cubed plus 5 minus 3 or something to that effect. And it's just the chain rule run in reverse is then called the famous backpropagation. I'm only putting this up here, not because we're doing a class on neural networks, no, but just to show you that that statement I made was very true, that you only need three things. And this is an example of that. All right. Now, another example. What is this? I didn't put a name on this one. What do I have up here? Take a second and look at this arrangement. And I want somebody to say what that is. What's going on here? What algorithm does that describe? I know a bunch of people have said it. Okay, good. So this is a generative adversarial network, right? Very important. The first set of, generative AI deepfakes that made a splash, what is already getting to be probably 5-6 years ago now, where from this algorithm, right? And the idea there is you have two neural networks that are fighting with each other. One of them is generating fake data, and the other one is trying to distinguish fake from real. But they have the same loss function up until a negative sign. So one's loss is the other's gain. That's it. And why do I put this up here? Not to talk in detail about GANs, but to express the point that what is your latent noise? What has been sampled to do the generation? Probability. Training. We just looked at stochastic gradient descent, derivatives, right? Then you're doing a sampling over expectation, which is an integral, all right? And so again, no matter how sophisticated, complex the algorithm is, it comes down to knowing what the fundamentals are. Here's another example. This is what? Take your time, look at it. What do you think this one is? Yep. Variational autoencoder. I heard somebody say that. That's exactly what it is. And again, same deal. In this case, you're starting out with data. You are reducing the dimensions of the data. Once you hear the word dimension, you know linear algebra, right? There's some notion of a space that has vectors, eigenvectors, Hilbert space, whatever you want to call it, higher dimensional space. And you are decreasing the number of vectors. You are projecting the data onto a smaller subset. And that's a latent space. Now, with the VAE, that latent space encodes the statistics. Again, we're back in probability. Now you see a Gaussian distribution, the mean and the variance. And then you have to, from that, sample that probability and then do your training again and reconstruct that data. And you have your loss function. And then you're doing stochastic gradient descent and boom, that's it. And trust me, every single AI algorithm is that simple. Especially once you see it, you've seen it. And you're like, is that it? That's it. Okay. But to get there, you need to have the math in your belt. So invest in that time to make sure that you didn't go the wrong way in trying to learn math. You went the right way. You got there efficiently. You got there effectively. You knew why you were doing it. You'll be in a place where no matter what algorithm they put in front of you, trust me, you spend some time, spend a few days looking at it, boom, light bulb's going to go off. Why? Because you know what all the blocks are, what are all the parts that put that thing together for you. Okay? Now, what about this one? Another example. I'm just trying to prove to you that what I said was true, that there's some fundamental math that is the same and that explains every single AI algorithm, no matter how fancy anybody tries to make it. This one is the transformer. Now we're in the age of the LLMs. These LLMs are very powerful. These LLMs are now even functioning as software developers. They're functioning as avatars. They're functioning as agents, security agents. They're functioning as marketing executives. They're doing a whole lot of stuff. And they're doing it very quickly. Where does all that come from? It comes from the math. And again, you can look at any part of this architecture, whether it's the embedding process that resulted in your tokenization, or whether it's the end-to-end training loop, right? With an autoregressive process or not, whatever the case might be, what you would find is at every point in this process, there's nothing but one of those three parts that are in play. All right, good. So again, I've taken the time. I had no idea that this whole year would be a math year for me. It just kind of happened, the opportunity presented itself, and as God will have it, I walked right into it. And I've been working on the math for much of this year. And this is the breakdown. So this is what I've distilled everything down to this. Like, okay, if somebody says, I want to be strong in math, I want to be in a place where it doesn't matter where they put you. They could put you inside the R&D department at, you name a company, OpenAI, Google, Amazon, whatever, or a startup, anywhere, you would be on day one, you would be ready to make contributions and to understand everything that they're doing or they're talking about in there, as relates to AI, as relates to math. All right. So this is how I've put it together in only 20 chapters, less than 400 pages. What are these chapters? Chapter 1, the true history of AI. You will notice that the historical context is always so important. Why? Because when you're asking yourselves, who came up with this? What was the actual problem they were solving? You don't see that everywhere, and I've noticed that is so informative in terms of just informing what these mathematical constructs are, where they came from, what was the actual intent. You get a deeper level of understanding. So that was the first chapter. Second chapter, the building blocks. A lot of what I just talked about, those three parts. Calculus, quick overview. Calculus, linear algebra, and probability. And then some of the basics, linear regression, logistic regression, constraint optimization. We've heard of Lagrange multipliers, Kirsch-Tucker algorithm, etc. In just the essentials of what you need. Support vector machines. Fourier transform. What did I just talk about? Signals processing and how it's everywhere. How the fact that I'm in Houston speaking and you can hear me in Lagos, right there, University of Lagos, is a signal over a wire that's gone different places. Parts of it might have gone through the internet, satellite, fiber optics, subsea, everything. Different ISP providers, bam, 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 boom, and then decode that information and present it, right? Fourier transforms, eigenvalue decomposition. I talked about linear algebra. This is the language of the physical world. The idea that you have a set of vectors or eigenfunctions, and you can collapse any data set and represent them in that term. That is you need to understand that. And then singular value decomposition, principal component analysis. These first 10 you can think of as classical foundational building blocks that are so key. And then the second 10 chapters or the second half get you straight into deep learning. And the first chapter, or chapter 11 of the book, chapter 1 of part 2, is neural networks, right? Stochastic gradient descent, loss function, etc. How you do that. And then deep reinforcement learning, very important. That's going to play a big role in the future. We've heard of AlphaGo, right? We've heard of the idea of gameplay and how you can solve a lot of problems with that. You need to have an understanding of that. It's a little bit of a different language from the rest of how AI has evolved. And then I talked about generative adversarial networks. These are generative models. Generative AI is such a big word these days. This is it. Generative adversarial networks, variational autoencoders, and then diffusion models. Diffusion models are so key when you look at things like Sora, like Kling.ai, ImageN, et cetera, and text to video or text to image, the fact that you can say anything, you can think about anything in your head that's never existed before, and you can just put it in a prompt and boom, it comes out. I kid you not, within probably 2 years from now, right? I know this has been recorded. We will probably get a full feature film where somebody just, writes a script and without any Hollywood actors or anything, you have a real indistinguishable from real movie generated. And then a few years after that, it's going to get to where it's a commoditized service that's in your home. Instead of Netflix, you can just say, okay, I want a movie, and you'll just describe some aspects to it, and then you can leave the AI to fill in the blanks, for you, and bam, you'll be watching a movie that no one has ever seen before. Now, this is not just for entertainment, because the idea of diffusion models and this powerful notion, we're going to see that within the realm of pharmaceuticals and drug discovery. When you know certain aspects of a disease and the mutations that exist, or the receptors, transmembrane receptors that are drug targets, you can imagine a world where I can say there's a certain mutation that's causing diabetes, and I can describe that. And then I can say, create a drug target, a drug for this target that halts that process. And with nothing but compute power, boom, you've got a new drug that actually works. And not only works, has been tested in certain contexts. So that's the future that we're going into. So this is really powerful stuff. So it's very important to be in a position whereby we understand what are the various aspects that will come into play. The math is what I'm talking about here today, but there are other aspects such as regulatory, such as financing, such as cybersecurity, such as ethics, such as representation. When you understand the power of this technology, you would know that all those parts, really have to be at play, and that everybody's got to be awake, to what's going on, and to what the opportunities are for this type of a powerful technology in either direction. And then the chapter 16 is word-to-vec and embedding. That's very important because that's the entry point for LLMs. So it's important to understand that. It's a neural network that trains something in a manner that it encodes semantics into the tokens. And it's just a neural network. And the training is really just based on proximity. Words that are near each other typically tend to be related to each other. And that's it. That's your training set, and that's how you get that to work. And then the attention mechanism is you all are paying attention to me, but there's also some other stimuli around you that you're ignoring. So we've taught neural networks to do the same. That deserved a chapter of its own, chapter 17, and then transformer. Transformer is really attention mechanism with a few other bells and whistles around it. And then contrastive learning is very important because it's the idea that as opposed to writing your algorithms, right, or getting, you want to curate data. Oftentimes we've heard of the importance of cleaning your data and getting your data to look a certain way. That's important. But guess what? There's a lot of data in the world. How about we make our algorithms go find the data in the way that they are without having to change the data? For instance, on the internet, you have alt text embedded in images, and you can do a Google search and there's tons of images. With an algorithm like this, contrastive learning image pre-training, you are able to go after the data in the wild and co-train a joint latent space. And that's a key part of these text to video models. And so that's described in detail in the book. And finally, LLMs, which are so critical to what we're doing. So we're coming to the end of that. I was here. And LLMs, which are so important to what we're doing. So I talked about the importance of various modalities of learning. And not everybody, learns the same way from a book or a research paper. The way that I'm talking to you now is relatable to you. And it would be different if I had typed up a paper and emailed it to you. with these same points, it wouldn't have the same effect, right? So that's very much understood. And so what I've done is I've actually recorded the entire book in lecture format. Even behind me right here, I think that's something on diffusion models. And so I've done the whole thing and just getting it prepared. Should be out in November at some point next month. And I would like to make that accessible to you all to be able to access that and learn from that. Yeah. So it's been a great project and a great opportunity for me. I see Dr. Bio. And so on that note, I just want to thank all of you. I want to congratulate you for making it to Data Science Nigeria Bootcamp 2024. I want to congratulate and thank the team, and especially want to thank Dr. Bayo Adekombi for the opportunity he has given me to be a participant and board advisor of DSN almost since its inception. And I've really benefited and really love this community. Thank you so much.
Wow, wow. Please, can we give Dr. Odaibo a super round of applause? Okay, great, great. We're going live to a very important session now. Dr. Odaibo has introduced the book to us. We want to formally unveil the book in Nigeria, the Nigerian way. Great. First, I will do some introduction first, and then we'll just go straight to the screen. I'm sure you can see the screen now. This is the book, so you can start scanning it so that it leads you to where it is on Amazon. You can tell your uncle in the US that this is the best December gift that they should buy for you. So tell your uncle, your brother, everybody you know in the US, please order this book for me and make it the best gift for the season. I tell you, it's the best you can get. So let me just do some highlights. First, let me quickly talk about the author before we unveil. As you may know, Dr. Stephen Odaibo is the first and only ophthalmologist with advanced degrees in mathematics and computer science. I don't know whether you understand what that means. Is the only medical doctor who has gone for advanced study in ophthalmology as the doctor of the eyes, and then went further to do masters in computer science and another masters in mathematics. Please, he deserves a round of applause once again. Great, great, great. So the book is 300 and the book is 385 pages. So if you go in there, you're going to have an amazing time of studying and of reading. It's 385 pages of 20 chapters, like I said. And I can assure you that people are already reviewing the book. One of the reviews says, "Great find for me. It is exactly what I needed to keep abreast of the maths in AI without being overwhelmed. Filters out a lot of noise and focuses on the core mathematical concept in machine learning." That is on Amazon. That is how good it is. Now, Dr. Stephen Odaibo is not just an advisory board member of Data Science Nigeria. He has been part of our journey. When we opened, in the same university where you are, where you've been in the last 4 days, it came all the way from the United States. It came down there about 6 years ago when we opened our first AI Hub to facilitate a workshop, on innovation. That is how committed he is. And of course, if not because the news came to him very late, he would have made it to Nigeria like he has done for several other boot camps that we have done in the past. He's always coming to Nigeria to teach, to mentor. And when you see him in class, you will not know that it's him. I mean, with so much passion and energy and commitment. Dr. Stephen Odaibo, we thank you for your commitment to what we do. And of course, he's also supporting our students as well. It takes a lot of our students for internship, and some of them are doing amazingly well,
Yeah.
and kudos to him. Some of them are working for top organizations across the world, and some of them are doing PhD, University of Maryland, and several parts of the world.
Yeah.
Through his mentorship that he offers students who really want to go far. Ladies and gentlemen, we want to unveil the book. And to do that, I would like to call to the podium if you are a master's, if you are a mathematics major, PhD or master's, can you wave your hand? Mathematics major, PhD or master's? Maybe we should start with PhD so that we don't have too many people. So you are a PhD student and you are a maths major. If you can wave your hand, you're going to join the unveiling in the front. Do we have anyone? How many people do we have?
We have one.
How many?
We have two.
Two, okay. So we're going to move to medicine. If by chance you've done medicine and you are in the room, we want to find everybody that represents Dr. Stephen Odaibo to unveil the book. So if you have studied medicine and you are in the room, please can we clap, please can you come to the podium? You studied medicine? Okay, good. Now, computer science. So if you have done computer science, PhD level computer science, you are also welcome to join us on the podium. PhD, you already have your PhD as in computer science. Please, can you join us on the podium? Please, can we have the banner by the side so that we do not lose? Yes, 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 yes. Please, can we clap for them as they walk up to the podium? Great. The next thing I will have said is that do we have an ophthalmologist? I'm not sure we're going to have that, but we have Dr. Odaibo joining virtually, so that makes it a compliment. So on behalf of the data science Nigerian community, in celebration of the commitment of the Dr. Stephen Odaibo to knowledge, we're glad to unveil this amazing book, Foundation of Machine Learning, Mathematics for Machine Learning, to advance learning, to advance practice, to promote best practice, and to help us raise world-class talents who are not just, drag and drop, who understand the fundamentals, and who can promote innovations in the practice of machine learning. Congratulations, Dr. Odaibo. Thanks for all that you do. Please, can we give him a standing ovation wherever you are? I'm standing where I am. Give a standing ovation. Please, can we stand wherever we are and give Dr. Odaibo a standing ovation for his commitment?
Oh, wow.
Thank you. Please scan it, send it to your uncle, your brother, let it trend on social media. Let's get people to buy the book, use the book, and impact the book. Of course, on Friday, we're going to announce the AI School of the Year, and that school is going to get we're going to buy some of those books, and it's going to be part of what we're going to give you to use in your school. So thank you so much, Dr. Odaibo. We celebrate you. We acknowledge you. Thanks for all that you do. And for all the people who have come to the podium to represent Dr. Odaibo, round of applause to them. Thank you very much, everyone. Let's enjoy our evening and have an awesome evening. Thank you so much, Dr. Odaibo. We celebrate you.
Thank you so much.
Thank you very much.